Good morning, students. Chapter 6, Work, Energy and Power. Yes, we will discuss some questions. See here, a body is moving under the influence of a source of constant power. Its displacement in time t is proportional to t raised to 1 by 2, t raised to 3 by 2 or t square. Yes, you are given constant power and you have to find what is displacement. Displacement depends on time according to which relation. See, first of all, you are given a source of constant power means you are given link. You have to start from from power. What is equation of power? Power P is equal to here it is F. Okay, yes, I have to find displacement. Then see how to find. Here it is. Power P is equal to F means ma V as it is. Okay, now P is equal to M. I can write this A is equal to dV upon dt. Here it is V. Clear about this? Okay. Now see how to write this term. P upon M dt is equal to here it is dt. Clear about this? See what actually we have to do in this question. First of all, from P is equal to Fv, we have to find relation of V, means equation of V, and then from equation of V, we have to find what is equation of X, that is displacement. Okay, so P is equal to Fv, T is equal to MAV, P is equal to MdV upon dt into V. Clear about this? Now, only terms having V on right hand side and other terms on right hand side. Okay, so now it is V dV, Pm dV. What we have to do? Yes, we have to integrate this equation. We have to integrate this equation. How to get integration? See, integration P upon M dt is equal to integration is equal to this integration dt. Clear? Now see left hand side. Left hand side. P, you are given a source of constant power, means power is constant. M, mass is always constant. So P upon M, it is constant, so it is out of integration. It is out of integration. So P upon M out of integration, here it is only integration P. Clear about this? Is equal to, here it is integration V. Any doubt? Okay, yes, I can also write this term this side. So here it is integration V dV is equal to P upon M integration. Now V dV integration is with respect to V of V. You know equation. It is V square by 2. It is V square by 2. What is integration of V dV? It is V square by 2 is equal to P upon M. Integration means here it is T. Okay. So yes, V square is equal to 2P upon M into T. So what is value of V? Yes, V is equal to, it is under 2P upon M. So yes, I can also write this equation as V is equal to, it is under 2P upon M T raised to 1 by 2. Square root means yes, I can write 1 by 2. So if you are asked, here you are asked if displacement time t is proportional to, but if you are asked what is velocity, then yes, here velocity is proportional to t raised to 1 by 2. Here velocity is proportional to t raised to 1 by. But yes, you have to find okay, what is relation of displacement. What is relation of displacement? Then how to find relation of displacement? See, from this equation, how to write? V, I can write V is equal to dx upon dt is equal to, it is under root 2p upon m t raised to 1 by 2. Yes or no? Yes, it is. Yes, it is. Okay, we know that V is equal to, it is dx upon dt is equal to, it's come as it is, t raised to 1 by 2 as it is. So now if I am taking dt this side, then here it is dx is equal to under root 2p upon m t raised to 1 by 2 dt. So again this dx is equal to this equation. So again we have to integrate this equation. So see how to take integration. See here it is integration dx is equal to integration this side. What is total term? It is 2p upon m t raised to 1 by 2. Here it is dt. Simple. Dx is equal to under root 2p upon m, t raised to 1 by 2 dt. Take integration on both sides. So integration dx is equal to integration under root 2p upon m, t raised to 1 by 2, and here it is dt. Integration dx, yes, you know it is x. Under root 2p upon m constant. Under root 2p upon m constant. So it is out of integration. Under root 2p upon m constant. Okay, here it is only integration t raised to 1 by 2. Clear about this? Okay, so yes, x is equal to, it is under root 2p upon m. Integration t raised to 1 by 2. Yes, you have to remember this equation, that is integration x raised to n dx is equal to x raised to n plus 1 upon n plus 1. Yes, you have to add one power. 1 by 2 plus 1 by 1 by 2 plus 1. 1 by 2 plus 1, it is 3 by 2. So it is t raised to 3 by 2 upon 3 by 2. Any doubt? Any doubt? Now see here, 2 constant, power constant, m constant, 3 by 2 is also constant. So this whole term we can consider as constant. So x is proportional to t raised to 3 by 2. X is proportional to t raised to 3 by. Clear about this? So yes, again you are given a source of constant power, its displacement in time t you have to find. Okay, so first of all, P is equal to Fv, F is equal to Ma, A is equal to dP upon dt. From this, first of all, you have to find what is equation of V. Yes, it is equation of V, and it is velocity in time t. Velocity in time t is directly proportional to t raised to 1 by 2. Velocity in time t is directly proportional to t raised to 1 by 2, and displacement x is proportional to t raised to 3 by 2. So yes, there are two questions in. Okay, first relation of velocity and relation of displacement. Clear about this question? So yes, this question is based on integration. This question is based on integration. Now next question. See what is next question. A body initially at rest undergoes one-dimensional motion with constant acceleration. The power delivered to it in time t is proportional to, yes, you have to find power. You have to find power. So again we will use equation of power, that is P is equal to, here it is F(A). Power P is equal to F. Yes, what is F? It is Ma, and here it is V. Ma, and here it is V. Clear about this? Now see, it is simple question. Mass m, it is always constant. Mass m, it is always constant. Okay, A, it is acceleration. See, a body initially at rest undergoes one-dimensional motion with constant acceleration. Means acceleration is constant. Yes or no? Yes. A body initially at rest undergoes one-dimensional motion under constant acceleration. For uniform acceleration. We know this equation. V is equal to V0 plus kT. Yes or no? Yes, it is. So V is equal to initially at rest. So V0 is 0. So plus kT. So yes, V is equal to, here it is kT. V is equal to, here it is kT. Yes or no? Yes, it is. Yes, it is. So here I can say as acceleration is constant, V is proportional to t. Here V is proportional to t. Now see, here is equal to, it is m. A. V is equal to, it is at. M constant, A constant. So P is proportional to t. P is proportional to t. So yes, it is again one simple question. Okay, when it is moving with constant acceleration, what is power delivered to it in time t? So power P is proportional to t. See how to make these types of relation. Okay, if you have to find relation between any two quantities, another quantities must be constant. See in this equation also, x is equal to, that is what this whole term, but 2 constant, P constant, M constant, 3 by 2 constant, then and then you can write x is proportional to t raised to 3 by 2. Okay, if x depends on another variable, then you cannot write only okay, x is proportional to t raised to 3 by 2. Similarly, in this question, m is constant. You are given constant acceleration, so acceleration is constant. So yes, power p is proportional to. Clear? So these are two questions which are based on relations. Now next question is, see, a particle of mass m moves on a circular path of radius r. Its centripetal acceleration is kt square, where k is constant and t is time. Express power as function of time. See how to find this question. You are given a particle of mass m moves on a circular path of radius r. On a circular path of radius r means it is performing circular motion. It has some centripetal acceleration, and that centripetal acceleration is given by kt square. So I can write centripetal acceleration v square upon r is equal to kt square. Yes, you are given centripetal acceleration is kt square, where k is constant and t is time. You have to find power as function of time. Yes, power, which equation we will use? Power p is equal to ft. And yes, what is f? F is equal to, here it is mk. So here we have to form terms like this. See how to find v square is equal to k t square r. V square is equal to k t square r. Yes or no? Yes or no? Yes. So first of all, I will differentiate this term. Okay. How to differentiate this term? See, here it is. It is 2v dv upon dt. Is equal to, here it is equal to, okay, it is 2 ktr. Differentiate this equation with respect to time. Okay, so yes, here it is 2v dv upon dt is equal to 2 ktr. 2v dv upon dt is equal to 2 ktr. So this 2 cut. Clear about this? Now this dv upon dt, it is called acceleration. So here it is v. Acceleration is equal to, it is kt is equal to, it is ktr. So now see, we have a and v. Now we have to multiply m on both sides. So if we multiply m on both sides, we will get m av is equal to it is m ktr. Here it is m ktr. Now m av is, it is f into v, m ktr. So Fa, here it is nothing but power. So power P is equal to, it is mk/tr. So therefore power P is proportional. M is constant. K, it is constant. R, that is radius, is also constant. So we can say P is proportional to. Clear about this? So yes, again it is one question which is based on relation. Again, how to find centripetal acceleration? V square upon r is equal to kt square. V square, it is 2v dv upon dt. Clear about this? Okay, so yes, it is one question which is again based on relations. Okay, now what is next question? See, here it is, next question. Potential energy of particle on its highest point is 3 by 4th of the value of its initial kinetic energy. Then the angle of projection is. See, here it is. It is figure. Okay, like it is x-axis, it is y-axis. At this point, it is thrown with initial speed v0 at angle theta. Clear about this? It is point of maximum height. So yes, it is point of maximum height. So we can say this height is, it is h. Okay. The potential energy of a projectile at its highest point is 3 by 4th the value of its initial kinetic energy. Means how to write? See, potential energy at maximum height is 3/4 its value of initial kinetic energy. Its value of initial kinetic energy. Its value of initial kinetic energy. Now potential energy at maximum height from ground, what is height? It is h. So yes, we know what is equation of potential energy. It is mgh. Why capital H? Maximum height is equal to 3/4 of initial kinetic energy. Initial speed is v0. So here it is half mv0 square. Clear about this? So now you have to find what is angle of projection. Where is angle of projection? Where is angle of projection? So yes, again this question is combination of chapter number 4 and chapter number 6. That is motion in plane and work energy power, because you have to now write equation of H. Okay, what is equation of H? Mg. Equation of H. What is equation of H? It is v0 square sin square theta 0 upon 2g is equal to this side 3/4 half m0 square. Clear about this? So yes, this m cut, this m cut, this 2 cut, this 2 cut, v0 square cut, v0 square cut. Yes or no? Yes, here it is. Now remaining terms are yes, this g cut, this g cut. So remaining terms are sin square theta 0 only left hand side is equal to this side is 3/4. This side it is 3/4. So sin theta 0 is equal to it is root 3/2. Sin theta 0 is equal to it is root 3/2. And therefore yes, theta 0 is equal to here it is 60 degree. Theta 0 is equal to here it is 60 degree. Clear about this? So yes, it is one easy question, but you have to combine two chapters. Chapter number 4, that is motion in plane, and chapter number 6, that is work energy power. And yes, again you have to remember, at this point it has only kinetic energy. At this point its potential energy is 0. Why? At this point it has only potential energy, its kinetic energy will be 0. Clear about this? So yes, for projectile motion you are given this relation. You have to remember equation of H, that is maximum height obtained by projectile. v0 square sin square theta 0 upon 2g. Okay, the angle of projection theta 0 is equal to it is 60. Angle of projection theta 0 is equal to it is 60. Clear about this? Okay, now next question is, see, a bullet is fired into a huge wooden block. The bullet, while moving inside the block, loses half the velocity when it travels a distance 6 cm inside the block. How far would it go inside the block? Resistive force is constant. See here, what is question? Let it is one wooden block. Let it is one wooden block, a huge wooden block. Okay, a bullet is fired into a huge wooden block. A bullet is fired into a huge wooden block. While moving inside the block, loses half the velocity when it travels a distance of 6 cm. So for example, see, this bullet is moving. When it is outside this block, let its velocity is v0. Let its velocity is here, it is v0. Clear about this? When it just enter this wooden block, let its velocity is v0. Now what is you can see here? The bullet, while moving inside the block, now bullet is moving inside the block, loses half the velocity when it travels a 6 cm distance. It travels distance 6 cm, and if it is here, now its velocity becomes v0/2. Yes, because you are given, okay, the bullet while moving inside the block loses half the velocity when it travels a 6 cm distance inside the block. Your question is, how far would it go inside the block? How far means what is further distance? up to which this bullet will move. Will move means how far means at this point bullet will stop and its velocity will become 0. Bullet will stop and its velocity will become 0. Clear about this? So yes, how far would it go inside block? How far would it go inside block means where bullet will stop? Where bullet will stop? At which distance? At further distance. Where bullet stops, we have to find that distance. Yes, we have to find this distance. X is equal to question mark. Clear about this? Okay. So yes, here you are also given resistive force is constant. So see, resistive force is constant. It means acceleration of bullet. Acceleration of bullet is constant. Acceleration of bullet is constant. Yes or no? Yes. Now how to find this question? See, for this case, first V0 6 centimeter, V0 by 2, and yes, acceleration is constant. Acceleration is constant, and I am assuming that constant acceleration of bullet is constant, and that is A. That is A, for example. Okay. So now for this AB, and then here it is C. Okay. For this part AB and BC, we have to use the same equation, that is V square minus V0 square is equal to 2AX. We have to use this equation. How to use this equation? Chalo, for AB, it is initial velocity, it is final velocity, it is distance, and acceleration, that is constant. So V square means final velocity. So here it is V0 by 2 whole square minus initial velocity is here it is V0 square is equal to 2, A that is A, and X here it is 6. And down. Okay. So here it is V0 square by 4 minus V0 square. Here it is 16. Here it is 6 into 12 means it is 12. And now V0 square by 4 minus V0 square means it is minus 3V0 square by 4 is equal to, here it is 12. Here it is 12. So now this 3 into 4. Before, if you bring this side, here it is minus V0 square upon 4 into 4 will become 16 is equal to A. So A is equal to minus V0 square by 16. A is equal to, it is minus V0 square by 16. Now the same equation you have to use for this part BC. Okay, again this equation. See, for this BC part, it is initial velocity now. It is final velocity. Initial velocity, final velocity. So yes, V square minus V0 square is equal to 2AX. Final velocity 0 square minus initial velocity, here it is V0 by 2 whole square is equal to, here it is 2A, and X we have to find. X we have to find. Clear about this? So therefore minus V0 square by 4. Clear? Minus V0 square by 4 is equal to 2. Put value of A. What is value of A? Here it is minus V0 square by 16, and here it is X. So first this minus minus cancels. Okay, V0 square cut, V0 square cut, 4 into 4, 2, here it is 2, and if you bring this to this side, then X is equal to 2 centimeter. X is equal to, here it is 2 centimeter. Clear about this? So yes, it is one simple question in which you have to find V square minus V0 square is equal to 2AX. V square minus V0 square is equal to 2AX for part AB and then for part BC. Clear about this? Yes. Yes, it is one question, simple. Okay, simple question. Yes, you have to note this. And yes, this question you can also solve with the help of work energy theorem, that is W is equal to delta K. W is equal to delta K. W is equal to force into displacement, and delta K means final kinetic energy minus initial kinetic energy. You will get the same result. Okay, so yes, with this for today, this is it.